So here I'll just walk you through this Lewis dot structure of clf3. So as usual, find the number of valence electrons. So there are a total of 4 atoms here, 1 chlorine, 3 fluorines, and each of them is in group 7. So there are 4 atoms, each with 7 electrons. There need to be 28 total electrons. And we know chlorine is going to go in the middle because it's in a lower period in the periodic table, and because there's only one of them. That's just the way it usually works out, is that if there's a bunch of one kind of element, it's not going to be in the middle. Next, we have to satisfy the octet rule, so I'm going to give lone pairs to every atom until every atom has an octet. I jumped ahead and got all the fluorines, and now the chlorine needs one electron pair. Now here's where we count up the electrons in our structure and compare it to the number we calculated at the beginning. And when we count up the electrons, 2 per lone pair, 2 per bond, we come up with 26. And here's where this problem is different from the problems we've been seeing. Usually we have too many electrons in our Lewis dot structure and we have to make double bonds. But here is where we have less than the number we should have. So we only have 26 in our structure. We need to get more in there, and here's what you do when you need to put more in there. You just put them on the central atom. So here chlorine will have 2 lone pairs. And because those lone pairs are there, this molecule is going to have a T-shaped geometry. Let me show you that. Let's rotate it like this. So there's our T, and here are the electron pairs. One is coming out at us, kind of. So I draw a wedge. The other one's going back into the computer screen. So I draw a dash. And these guys are all on the plane of the computer screen.
Made with Doodlecast Pro.